Okay, this is the last video for now. Now you're going to be watching these all together and say, I wonder why I'm saying this. This is 4 in a row and that's my limit. So if you've done 4 in a row, please take a break. But then it must be midnight. Okay, so we've got the sketch below that shows two graphs. Y equals k over x over the interval negative infinity 0. Let's just pause on that. What are they saying? Well, they've got a hyperbola, and if you drew a hyperbola normally, and we've got hyperbola here that's in the first and third quadrants, it would look like that. But they're saying negative infinity, we're just going up to 0, so we're not going to worry about that part of it. It's just this part here that we're worried about. Okay, so that's what that bit there is talking about. Okay, and y equals mx plus c. Cool, our beloved straight line that we've seen for years and years. Determine the values of k, m, and c. And I've just rewritten these coordinates so they're really nice and big. Now it looks like it's more complicated than it is. Or maybe it doesn't. Maybe like, hey, this is easy. But I definitely looked and thought, oh, if we're going to find the equation of the hyperbola, it feels a bit difficult. But step by step. And start with our straight line if we can. Straight line is going through 2 points. This point and this point, they're unlabeled. How do we determine the equation of a straight line running through 2 points? Well, yeah, start with y equals mx plus c, or have that, mx plus c, just checking that and say k. And we can work out the gradient and then sub for the other point. So our gradient, m equals rise over run. Okay, let's start. I always start with the run. So we're running from -5 to -1. So we're running along by 4. And we're rising from 0 down to -4. So we're going -4. Therefore, our gradient is -1. Okay, and negative feels right. It's going down. -1, well, our graph's not to scale, so we can't really tell if that feels right or not. Okay, so y equals minus 1x plus c. Let's sub in a point. I'm going to go for this point up top left here because it looks a bit easier. So 0 equals -5 plus c. Cool. Well, therefore, c equals 5. Why does that feel wrong? Because c couldn't be a positive value. Then our y-intercept would be up here. So where's the error? Negative x. And our x is actually -5. So it must be -5. So 0 equals negative, and a negative is 5 plus c. So c must be -5. Okay, genuine mistake, to be honest, but picked it up because c being 5 didn't fit in. I thought that doesn't work. Okay, so c is 5. So let's finish off our equation and go y equals -x minus 5. Cool. And then we need to find out k. Now, as I said, finding out this, well, we know that y equals, what have they given us? K over x. K over x. Now, normally with a hyperbola, there's a bit of work to do. We sub in two values and do all sorts of things and look at our asymptotes. Well, we know that there's an asymptote here at 0 and at 0. In other words, we know q is 0 and we know that p is 0. All we need to work out is what this top value, which we'd normally have called a. Well, it goes through this point, -1, 4. So if we substitute that point in, k over -1, we've got an equation with only one variable to solve. Well, easy, then we can solve it. So multiply by -1. So these cancel. What you do on one side, we do on the other. So we've just got -1 times -4. 4 equals k. So y equals 4 over x. And positive value, that makes sense. A positive hyperbola we expect to be in the first and the third quadrant. And this is, well, it's not in the first, but it's down in the third quadrant. So that's what we expect. Okay, so we've got our two equations. Determine the axis of symmetry of the hyperbola. Well, for our hyperbola, we can, let me just, excuse me for a second. If we're working out our axis of symmetry, we can say, where's this line? So there's a line going like this to go somewhere like that. If we did a mirror of that function, it would be the same. Well, since P and Q are both 0, then our axis of symmetry is simply the most basic axis of symmetry, y equals x. Axis of symmetry only relies on P and Q, in other words, moving it left and right, up and down. Otherwise, it's always an x and a negative x. And yeah, this one's just fairly basic. It just goes through the origin, y equals x. Okay, determine the coordinates of A. Okay, what's A? A is, what is it? It's where the two graphs are equal to each other. So let's put the two graphs equal to each other. Now, how many solutions are we going to get? We should get 2 if we look at our diagram, because we should get A, and our other solution should be here. So once we put them equal to each other, we know our one solution is x equals minus 1. In other words, when we factorize, we're going to get something equals 0, and we're probably going to get bracket, 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 bracket. X plus 1 is going to be our one bracket. Or we've used the quadratic formula, and that will be one of our solutions. Let's see if that holds true. So we're saying this graph equals this graph. We're saying that this graph, minus x minus 5, the straight line, when does it equal 4 over x? Okay, then we want to solve this, so let's multiply both sides by x, so that cancels, and we just got 4 on the right-hand side. What we do on one side, we do on the other. So let's multiply this whole side by x and distribute it in. So we got minus x squared minus 5x. Rearrange our equation. I'm going to rearrange and put things on the right-hand side. X squared plus 5x plus 4 equals 0. And this looks simple enough to factorize. X, well, plus 4 plus 1. Hey, that matches what we thought, because we know from this one x equals negative 1 was going to be one of our solutions. There it is. And our other solution that really interests us is x equals negative 4. So this is the one we're interested in. Let's determine what the y value is. Normally I'd substitute into the straight line, but I think substituting into the hyperbola is going to be easier. So I'm going to go, the y value is 4 over negative 4 is negative 1. In other words, this point, when x is negative 4, y is negative 1. Which one was that? That was A. So, you know by now I like to label these things. That is A. And that's disappearing off the screen slightly. Let's pull it in here and do that. Okay. A little bit better. Right. So we've got A. We're pretty much there. This question hasn't actually been too involved. Determine the length of BC. This length here, if OD equals 6 units and BCD is perpendicular. In other words, it's at right angles. And it says it's at right angles. If you've done questions 1, 2, and 3, you realize that this is a long way around of writing, well, for B, C, and D, if OD is 6 units, we know that the x value is negative 6 of all of these. And for D, it's 0. So all we need to do is work out this y value, this y value. If you're given an input, how do you determine the output? Just substitute into the function. So let's start with our straight line, then a hyperbola. So negative 6 is our x value. But the key of the question was figuring out what to do, I think. So let's start with our straight line. So we got y equals minus 6 minus 5. 6 minus 5 is 1. So in other words, we've worked out that this point B up here is when x is minus 6, our y value is 1. And for the other one we're working out for C, when x is negative 6, what's y going to be? Well, y equals 4 over negative 6. This equals negative 2/3. So what's the distance between negative 2/3 and 1? Well, it's just that plus that. So we got BC equals 1 and 2/3. Is that all they asked us? Determine the length of BC. Okay, that's that one. Well worked so far. If you're getting this far, keep at it, and keep just working through systematically.